Okay, guys, how are we doing? Are we all set to continue? So basically, we can still go on to the BGP part, but since we are running late, uh, we'll be uploading the slide deck online. So you have to just go and do a git pull, and you'll be able to get all the contents. So that would include this configuration and troubleshooting steps, basically, whenever you are uh, not able to establish a BGP session and things like that, how to debug all these things, uh, that all these steps are all well documented, so you don't have to, you can just go out later in the day and just play along and try to debug things. So I'll start with PCEP now.
What happened to the other one? That,
Yeah, so the XRV exercise.
huh?
The XRV exercise?
No, Giles have set up for us actually.
Yeah, the league law.
Yes.
Yeah.
Yes. So
That's what he's saying. I mean, we could spend time doing that, but since it's already 4.
No, we have time, don't worry.
There's more stuff to cover. Probably we can come back to it at the end.
yeah. So what we can do is we can. There will be some XRB labs in PCEP also. We can quickly go through that, and if time permits, come back to BGP.
So the only thing that is different with the ExaBGP example that we saw is in ExaBGP there were only V4 prefixes, but in the XRV you will get the link state updates.
So in there actually, how many BGP peer we will set up? All the
No, again only one BGP peer.
Well, the same as ARAX for BGP link state, we'll basically export everything that goes from ISIS into BGP.
So to answer your question, it will be just one router that will have the BGP topology or the session connected with the controller, and on
three speakers.
yes, that will be the speaker, and on that you will be redistributing OSPF into BGP. That will be learning the BGP link state routes, and through REST APIs you can just read the link states.
No, if you have some time, 5-10 minutes.
Sure. I mean, yeah. I'm not sure if all the audience will stay till the end.
No, I
So
think, what Ajay is saying is in the precept exercise also we'll be using the XRV.
XRVs, yes. So I'll be walking you guys over the PCEP lab, wherein we'll be using the topology, the same topology. We'll be establishing LSPs through different routers. So you'll just get an idea of how the XRVs are used. So, yeah. So. So, how many people are aware of PCEP? I know a few of them are here, are good aware. Okay, so I just get a few hands up. So, I'll just quickly introduce this protocol. So, this is the full form of PCEP is basically Path Computation Element Protocol, where there is a server and there are too many clients. You can have like n number of clients. So the clients basically represents path computation clients, that's what it's called as. And every server, so here basically you can have the ODL is acting as a PCE, as a server. And all the nodes are pointing to the PCE, which is the path control element. And it is nothing but the protocol which uses a normal TCP session with 4189 as the port. And just like BGP, these are the message types that they are. To start with, there is one open and keep alive, which instantiates and maintains the PCEP sessions. Then there is a PC request, where the PCC requests the PCE to create a path for it. Then there is a reply that comes from the controller. That reply could be like positive or negative. It could be like, okay, I'm able to create an LSP for you. This is a positive reply given by the controller to the clients. The clients can be anything. It could be any routers that support the PCEP protocol. And there are various notification messages, and if there is any error, that gets notified with the PCERR message. So in PCEP, there are two ways you can create a tunnel. One is you can initiate the tunnel from the controller, in this case the PCE, or you can create the tunnels from the PCC, which is called as the PCC initiated tunnels, and you can delegate that tunnel to the controller, saying that this is the LSP I have created. Now you control it. You can adjust the bandwidth or play with it. So it's like there are two ways the LSP initiation process can happen. So any questions so far? Because I might be going a little faster, so please feel free to stop me whenever you want me to. So to summarize this, it's nothing but a client-server communication protocol in a very, very layman terms. And these are the RFCs that are supported in the Opendaylight. The point here to be noted is we have been supporting stateful draft 07 since Beryllium time frame. Before that, we had the stateful 02. And going forward, we'll be continuing to use that stateful 07 draft. And there is also a segment routing extension in PCEP. Yep, and there is support like diffserv, and the main RFC is RFC 5440 for PCEP. So if you see this, the slide deck, this is just to show that the topology or the network intelligence that we get from BGP can be leveraged by the PCEP protocol to push the LSPs. So basically, it will learn the network topology from BGP, and using that topology information, it can push down, it can create paths between the routers in a network. So that's the entire loop that you see how things between BGP and PCEP can be used to use the network intelligence and program the tunnels down below. So I have been talking about LSPs. Are you guys clear on the term LSPs? It is nothing but a label switched paths. And when I say label switched path, it is precisely an MPLS TE tunnel that uses basically like things like RSVP protocol and MPLS TE configuration to hold the tunnel. So how many people here are familiar with RSVP and MPLS TE? Okay, I see a few hands there. So as Ajay L had explained about how the base network topology YANG file has been there in the Opendaylight. So this PCEP topology model is nothing but it is augmented on the top of the base network topology model. So if you see here in this topology on the left, you will see the information about a single node. On the left, if you see, it has the information about the PCC client attributes. And on the right, it shows the information about all the LSPs or all the tunnels inside that particular node. So there is no concept of like in BGP LS, we can see or read the data about the termination points. You will not be able to see all those information here like BGP LS. Here basically you will see the information about the tunnel. When I say information, I mean that every tunnel would have things like bandwidth, then there will be a source point, destination point of a tunnel, and there is a new concept of arrows, it is called as explicit route objects. It is nothing but the hops or the IPs of the hops the tunnel is going through. So basically, we'll be doing all those in the lab. So if these things are new to you, just keep in mind that E-rows are just like hops, so that are used by the tunnel to be created. So this is a sample topology, PCEP topology model, and it's just nothing but the actual data representation of the previous slide. So on the left, if you see, it shows the PCC 10.18.132.98, which is nothing but a node. It shows basically what is the LSP capability and the stateful TLV information about that particular node. And within that node, on the right, as you see, it shows the information about the tunnels. So these IP address, I'm not sure if it is clear, if you guys can see it clearly, it is nothing but the hops the tunnel is going through. So if you see, there are 4 IPs, 8.8.8.2, 7.7.7.2, and 6.6.6.2. It's nothing but, so there's a source point, there's a destination point, and there are a number of hops between those source and destination points. So it displays these arrows information to the controller. So the controller knows that the tunnel is going through which hops. It knows about all these things. So am I going a little fast? Yeah, you had a question.
In your example back there, it's going through those hops.
Right.
But it's going through an MPLS tunnel, yes?
Yes.
So does the tunnel ID show up there in that path somewhere? Is that the LSP ID?
Yes, that's correct. Yeah. Anyone else has a question? Yeah.
Those IPP prefixes, what is that on the router?
So it could be 2 things. It could be the loopback IPs on that router, or it could be the in-band interfaces of that router being used. So either one of them it could be.
Yeah, I mean, normally, yeah, you tend to give the far end interface address of each route you're going through, and then at the end you'll have the loopback, which I guess will be that one.
Yes, the one at the end is the loopback, yeah.
But if you still like get the second routing, you can have different things in the arrow, for example, like the labels or whatever.
Yep. So this slide here is basically showing the various RPCs that we have in the Opendaylight controller. So on the left top, we see an RPC to add an LSP. So many people must be thinking, where does it sit in the Opendaylight thing? So if you want to send or create the tunnel from the controller and push it down to the router, this is where you would be using this. So add LSP is to add the LSP. There is remove LSP, and there should be one update LSP args that can be used. So these are nothing but the Yang models to create and update and delete the tunnels.
And those tunnels are coming from some application that's
Yes.
sitting out there that's,
Yep.
that's
That's correct.
gathered this knowledge
Exactly.
outside the scope of what.
That is what the Opendaylight controller exposes to the application, right? So, yeah. So do you guys want to start with the lab? So how many people are up for the lab? If you can just raise your hand. Okay, great. So I think the VM that the OVF file that was distributed had the PCEP topology up. So let me go back into the already installed. So you don't need to worry about these steps. Do you want to have this capture file or?
Yeah, so the PCEP plugin actually listens on TCP 41894. So instead of want to switch it to TCP 4189. So that would show you the messages that are getting exchanged during the PCEP exercise.
Yep.
So you could stop it and then start with different code.
So just make sure that you have the PCEP session up. Are you guys with me? And in the tutorial link, if we can just get started over the PCEP section. Sure. Just Wireshark, right? It's 4189, yeah. Oh, you have already captured the packets.
Yeah, so just stop it's already stopped, so options. So instead of the 1790, just change this to 4189.
Do we need to stop the audience over there? We have run a pure system. Yeah, audio system that we have run the
No.
XRBGP.
Oh, it's already? So well. Oh, okay. So, but why is it not showing the packet? Should I stop it?
No, because PCEP is not.
Oh, okay. It's not established. Okay, so let's move on. So can you guys go on the tutorial section of the PCEP and let me know once you guys are ready? Are the log sets, like log set on the controller? Okay. Are you guys with me? So there's a debug section in the PCEP tutorial page, which is optional right now. You can just go onto the Karaf client and then just copy and paste these log commands. So this will help you for debugging purposes. If there's any PCEP sessions which are not up or established, you can, just use these log messages. And here comes the fun part. So let's log in into the SJC router in the XRV. So assuming that you are already connected in your VPN. So if you just do a telnet and just do a router and tab, and then press one more tab, it will give you the list of controllers, list of routers. So go ahead and log in into the SJC. So the username and password is root or Cisco. Let me know once you guys are in. So once you're in the router, you can just run the show command, show MPLS traffic engineering PCEP here, and you will see a 198 series IP address which is already up. We don't need to use this one. What we'll do is basically we will configure the PCEP with the IP address of the VPN that you guys had got at the beginning of this lab. So if you guys just run bin check VPN status and get the IP address of your controller and copy, and let's see, where do we need to configure this? So there are two options. Basically, you can unconfigure this existing 198 IP, which I'll be doing, or you can add a new one. So configuring a new one. SJC. And there is an option here in the run config which says Cisco extension. It is not needed for today's lab, but it's optional. If you guys want to keep it, keep it. We don't need it. So let's see if the peering is established. So you must see that the peering must be up. So let's see if we could capture anything on Wireshark. So if you see here, there was a basic TCP protocol initiation at the first 3 lines. That was a 3-way handshake. And on the top of that, there was a PCEP session that happened that sent the open messages, and the communication between the SJC router and the controller was established. So there were a bunch of open messages, keep alive. There was a request and report being sent, that communication that happened. So you guys can analyze it, maybe just save the Wireshark files in your laptop and maybe go home and just analyze it. So there was the port that was used was 4189. And it is still on. So, so are you guys with me till here? Anyone who is lagging behind? All set? Anyone out there? All good? Okay, good. So here in the tutorial, you can just the reason that I have put this snapshot here is just to determine that RSVP is pre-configured on the SJC router, so you don't need to worry about any of those things. And same goes with the MPLS T router. So here we saw that this was the controller IP that I changed. I changed to the VPN IP, and we were able to establish the PCEP session. The Cisco extension thing is pretty optional, so up to you. And we reached at this step wherein we established the PCEP session. So these will be the sample snapshot log messages that you will be seeing on the controller once the PCEP session is established. Again, if you have enabled the debugs, the log debugs on your machine, you should be able to see that. Okay, so now the fun thing happens. Let's try to establish an LSP. And if you see here on the topology, we had the SJC router connected to the controller. So what I'm going to do is I'm going to create a tunnel from SJC to Seattle, and I am going to go through Portland. So there are two options basically out here. Either you can go through Portland or you can go through SFC. When you guys are doing your lab, you can just select any of the hops. The difference would be just an IP address. So let's try to create a PCE initiated LSP. So if you guys have your Postman up and running, just go in the PCEP section, and in the PCEP section you should have everything ready for you. So if I just walk you over the body, as Ajay L might have shown you guys earlier, there are various settings already done. So there's a source IP, there's a destination IP, and there should be some hops also. So PCEP tunnel hop 1, I think, is Portland, if I'm not wrong. Yeah, it should be Portland. And the last one should be Seattle, I guess. So let's try to just, so you don't need to change anything into the settings. It's already there for you guys already constructed. So it is reflected out here. So if you just click on the send button, and you got a 200 OK. So the command to verify on the router is show MPLS traffic engineering tunnels. Things to note here is the tunnel is operationally up and signally connected, and this indicates that this was a PCE initiated tunnel. Means this tunnel was created by the controller and pushed. So this was created and delegated by the controller. That is what it shows up here, and it should show the hops that it is going through right here. So it is going through 56 and 54, which is the two hops that it has taken to reach the destination. So any questions so far? Are you guys with me? Someone is lagging behind, let me know. Are we doing on time? Good. So let's see how it looks. So this was the add LSP RPC if I had shown in my previous slide decks. And this is nothing but the same thing. If you scroll at the end, you see this add LSP RPC call that I used to push the tunnel down to the router. And let's see how does the controller learn about this. So does anyone remember what I had told? What does the controller read or have the information about? Anyone in the audience? So no. So as I had mentioned explicitly that it will not read the information just like BGP-LS does, like having the termination point and things like that. It will have the information about the node, the head-end router, which is in this case the SJC router. And it will also show me the LSPs that are in that head-end router. So basically think of the head-end router as the brain that was in the traditional days. So the brain has been given to the controller. So now the controller is the brain. Just think of that way if you guys can not perceive the picture in your mind. So let's do a get operation. And if you see, this is the IP address of the SJC router. And it knows about the arrows, which is the explicit route objects. And if you search for It will also tell you the capability, which is LSP update capability, which is true, means the controller has the capability to update this tunnel information. And it should also show you that the tunnel has been delegated to the controller. This delegate flag here indicates that this LSP has been delegated to the controller. It is not in the hands of the router now. It has been, the control has been given to the controller now. If you see it false, means the controller has been taken back by the router. So this is how you distinguish between these things. And you should also see the operational status, which is up, which is good. And there is also the bandwidth information that shows up here, which is, you might be thinking, what is the 6 times A, like 6 A's and equal to, so it is, yeah, so it is nothing but the base 64 value of the decimal number. So say, for example, so this is 0 kbps basically, because I did not include any information about the bandwidth. So in the next lab, I'll be showing you how to update or send the bandwidth information from the controller to the router.
Can you go over that again? Because I know that like flow spec uses this as well if you want to do 0 bandwidth. I don't understand what this is.
So this is nothing but the base 64 representation of 0 kbps. Means there's no bandwidth signaled on this LSP basically. So there is a converter in the tutorial document that we have provided. There are links. So if you just put in 0 in, so if you, maybe I can show you in the tutorial. Yeah. Where is that link you had put? Below? Okay, so in the same page, you will, if you search for bandwidth, you will see this conversion tool that we have provided in this lab. So say for example, I am signaling a 400 kbps signal value. How does it come and reflect in the controller? So first we have to convert the kbps value to bytes per second, which in this case, so say for example, I'm trying to signal a 400 kbps signal LSP. So the conversion is like 50,000 bytes per second. And then use that bytes per second value and convert it into hexadecimal. So this is the hexadecimal value of that bytes per second signal value. And then from hexadecimal, you convert using base 64 encoding tool. I can go step by step, but since time is not like allowing us, we have provided the conversion tool for you guys, so you can go home and like try to play with this. So you will be able to convert. So this is how you will see AAAA here. So if you just put 0 here and change it to bytes per second, it will be obviously 0. And then change it to hexadecimal and put the hexadecimal value in the base 64 converting tool, and you will get the value AAA. Try it whenever you guys are free. Okay, so where were we?
I guess that's what I was saying earlier about, in reality, you probably have a real PCE signal on top of this. You probably wouldn't be going in by hand and figuring out your...
Yeah. Yeah. So we did the create PCE initiated part. Now let's try to update the LSPs with a different hops. So basically in the diagram, we went, I think, from Portland. We went, okay, I think we went from SFC to Portland. Now, that is the sample body that is in your Postman operation. So in the update, I have kept the other path. So if you guys want to change the hops the tunnel has to go through, you can simply just do an update operation here. So if you go see the update tunnel and check the body, let's see. So let's try to put the IP of this guy, which is 55.0.0.28 and 53.0.0.26. So in the tunnel hop 1, I'm going to change the hop information.
One more question, just back on the
Sure.
conversion. I mean, why for an application developer, why wouldn't you just make it whatever the bandwidth is, and then on the back end, Opendaylight's doing that conversion? I mean, why?
I think this is how it has been designed, right? I mean, do you want to take that question?
This one,
So the question is why it is in the base 64 format and why not?
all that stuff. The base 64, I guess, comes from that's just how it's encoded in the Yang model, or how Yang.
Yeah, maybe it is, must be already done in the Yang models.
Yeah.
Because it makes it harder, right? On the developer has to like write their own conversion tool, so then put it in just so it gets converted back again on the back end.
Yeah,
So it's
yeah.
kind of a combination of it's exactly wrapping what what PC protocol does, plus the fact that it's running with Yang, and that's where you get all the base 64 stuff. But you're right, that's where you probably need a higher layer for convenience API that does conversion for you. Yeah, we should probably have one.
Because in the BGP extended communities are the same thing for the same for like flow spec to do drops and stuff like that. It's the
Same stuff.
yeah.
So what I'm going to do is nothing but changing the arrow information. Oh yeah, thanks. So I always keep on missing that. And let me see if it did update. So if you see here, I did not rerun the command again. Earlier it was 56 and 54, so it should change the hops information through an update operation that I did from the controller. And it now is taking the same tunnel. There's the same tunnel, same source, same destination IP, but the hops are changed here. So that is where you can use the update LSP RPC to do this update operation. So we did the create PCEP information, the update LSP. So if you want to do the same update operation, basically with providing the if you want to signal the LSP with, say for example 100 kbps or 400 kbps, as I mentioned earlier, this is the base 64 conversion of 400 kbps. So you guys can try it later in the tutorial. Just put this bandwidth information in the same update LSP operation, and you can signal the LSP with 400 kbps. So yeah, so this is how it would look on the XRV. This was a 400 kbps information. And let's now delete the tunnel. So I'm going to go ahead and delete the tunnel. Make sure the tunnels are deleted. Yes, it is. So the second option to create the LSP is through the PCC. Means on the head-end router, I will be creating an LSP through the set of commands, and then I'll be delegating this LSP to the controller. So the head-end router here is creating the LSP and saying, please take the control over this LSP and you can do whatever you want. So what I'm going to do is I'm going to just copy and paste these commands on the router. So things to note here, what I'm doing here, I'm trying to tell what is the source of the tunnel, which in this case is the loopback IP. I'm giving it a name, which is foo. Auto route announce will help me to announce these information of this particular LSP to other protocols like IGP or OSPF or whatever you're using. In this case, I think we're using the ISIS protocol, and this is the destination of the LSP. And either you can put the path option to be dynamic, or you can explicitly say I want to go from this hop to this hop to this hop. So this dynamic basically uses the IGP protocol, which in this case is ISIS. So if I just do show running router ISIS, this is how it has been configured on each router of the Cisco D Cloud. So you don't need to configure any such things here. So let's see what happens. So the tunnel is up. The destination, source and destination is good. The hops information are there. Is there anything that we don't see in this tunnel? Any guesses? Or maybe I can just do a get operation in the postman. And any guesses why it is not showing the information of the tunnel here? It is showing me the node information, but it is not showing me the tunnel information. Quick guess here. So the reason it is not there is because it has not been delegated to the controller. So if I show you the configuration again, if I go back here, this T100 tunnel basically has not delegated the control from the head-end router to the controller. It is still taking the controller to its own. So what I'm going to do is I'm going to go back to the router, and I'm going to give the controls to the controller.
So in that case, so we are not populating the delegate field because wouldn't that be delegate false in that case?
So no, it has not been. The controller doesn't know about this LSP yet, right?
And it's a field it's a leaf within the LSP, so that's what.
The delegate false. It will come once it has been delegated. So what you can do is, in that case, you have to first delegate to the controller and then do an update operation from the controller saying delegate equal to false. So that will give you the delegate false option. So basically, give the control to the controller and take back the control from the controller. So it works like that. So that is where you will see the PCE delegation false. So there might be an instance when you have multiple controllers, right? And you control it with the, there's a command on the CLI that you control using that. So if you have, so maybe I can just run that command, show MPLS traffic engineering, PCPL. So by default, the precedence value I was talking about. So if you have multiple controllers and if the precedence value is lower than the other controller, then that will be the active controller, and the one with the higher precedence value will be the standby, and that is where you'll see the delegate flag false for the standby controller. So I will go back to the tunnel. So if you see here, it doesn't show that it has, this tunnel has been created by the controller. It has just been delegated to this controller. So let's check in Postman pretty quickly. And we do see the tunnel information. And let's search for, so if you see the delegate flag is set to true, means I have given the controls now to the controller. Any questions so far? I know I'm going a little faster because we have another topic, which is flow spec and BMP. So this is the same thing that I did here. I just configured the PCE delegation part here on the LSP, and this is how the configuration looks like. And there are quite snapshots also that in the same tutorial document that you will be able to see that highlights each and everything that I have spoken about. Okay, so let's see. Yeah.
How does the active standby controller selection happen?
So let me see, show you. So now I have a single controller here, right?
Yeah.
So by default, the precedence is set to 255. So there is an option in the CLI. You can change the value of the precedence lower than 255. So lower the value, higher the priority. So say for example, if I have another controller whose precedence value is 254, that will be the active controller, and this guy will be the standby. And then when I delegate the tunnel to the controller and do a get operation, you will see the delegate flag set to false for this guy and true for the one with the higher priority. Did that answer your question? Cool. Okay. So let's try to do an update operation and try to take back or just cancel the delegation basically. So what I'm going to do is I'm going to send this update body with the flag set to false, meaning I am going to give back the controls to the head end router. So the head end router created the tunnel, gave it to the controller. Now I can do this REST call through the controller and give back the control to the head end router. So this is just to show that it's on the controller end, it is so flexible that you can, using a single REST operation, you can do whatever you want to achieve. So so I've changed this to false. And let's see if so if you see, there is no information about delegation here. Delegation information has been has gone from here, meaning that this tunnel is now controlled by the router itself. It has not been delegated to the controller. And let's see how does it look in the get. And in the get, basically, controller does not know about this LSP at all. It has given back the admin rights and everything to the router. So you don't see any LSP information learned by the controller. So I quickly just came over the segment routing piece. So segment routing is quite similar to PCEP, as Giles had mentioned earlier. Instead of giving the arrows information, which is the explicit route objects that we gave in PCEP, we can give the information about the entire segment, basically. So you must be thinking, what is the difference between PCEP and segment routing? So in PCEP, we need things like RSVP and MPLS-T. While in segment routing, the tunnel can learn the information through interior gateway protocol, which is the IGP. It does not require any information about what is RSVP, what is the MPLS-T information, or configure things like that. So it uses the information from the protocols like OSPF or ISIS, and then it basically helps to create the segment routing thing. So I have
It still works with BGP-LS and PCEP.
Yes.
But you add additional information to BGP-LS to give you the segment information. So you can learn the labels directly from the IGP. And then, when you come to do the PCEP stuff, instead of the router having to signal LSP with RSVP, it can just program in the label stack at ingress. And I guess the key with segment routing is it fits really well with this controller-based model, because you don't have the bandwidth counting in the network anymore, and that's the thing. So you really need to take it out to a controller. So I think we'll see a real alignment between segment routing and PCEP and use of controllers.
Yeah. So if you see, if I just unconfigure RSVP, this tunnel will go down basically in PCEP. But if I do the same thing in segment routing, it will be still held. It will be still held up. So that's what I have shown in the tutorial. So it's very, I mean, the postman collections also are updated. Should be under, so where did you keep? Okay, so I'm not going to spend time re-importing the postman collections because I think it was updated and not being pulled. In the meantime, I will be, let's see if there was anything left in the slide deck that I need to talk about. So one thing to note that there are two ways you can configure PCEP. One is through the 39 PCEP provider, which is kept in the same path where the 41 BGP file was kept. Just I think by default you don't need to change even anything. It's configured with stateful 07 by default. You don't need to change anything. Like if you saw that I did not configure any IP address on the controller, it was up by default. So that is the best part I like about PCEP. And of course you can use the netconf controller config netconf wait to do that. And the open config model is not available in Beryllium. It was introduced in Boron.
So actually PCEP doesn't have it.
Oh really? We don't have it in Boron? Oh okay, cool. So there's no open config model available at all. And if you want to just change the ID, so in the get operation that we did, there is always a PCEP topology ID that you can have. Here you can, so say for example, if you're doing things like 3-node clustering, you can have 3 different topology IDs for 3 different topologies instead of overlapping on each other. So that is one thing to be considered. And again, the troubleshooting steps are the same as BGP. The only difference is, I mean, I have spoken about this RSVP and MPLS-T part. So yeah, that's pretty much it. Do you guys have any other more questions that I can address before we move on to BMP?
Both doesn't need to be run in the network, PCEP and the segment routing. Only one is sufficient.
Yeah, one is sufficient enough, yeah. Either you run segment routing or you run PCEP. So it's mostly a design thing. I mean, whenever you design, you can choose between the two, if it is segment routing or PCEP, yeah. Cool, so let's switch our gears to BMP. So I'm sorry if I went through very fast. Since we are like running out of time, I have to go fast. So thank you guys. Extension in PCEP. Yep, and there are support like diffserv, and the main RFC is RFC 5440 for PCEP. Yeah. So if you see this, the slide deck, this is just to show that the topology or the network intelligence that we get from BGP can be leveraged by the PCEP protocol to push the LSPs. So basically, it will learn the network topology from BGP, and using that topology information, it can push down, it can create paths between the routers in a network. So that's the entire loop that you see, how things between BGP and PCEP can be used to use the network intelligence and program the tunnels down below. So I have been talking about LSPs. Are you guys clear on the term LSPs? It is nothing but a label switched paths. And when I say label switched path, it is precisely an MPLS-TE tunnel that uses basically like things like RSVP protocol and MPLS-TE configuration to hold the tunnel. So how many people here are familiar, good aware? Okay, so I just get a few hands up. So I'll just quickly introduce this protocol. So this is the full form of PCEP is basically Path Computation Element Protocol, where there is a server and there are too many clients. You can have like n number of clients. So the clients basically represents path computation clients, that's what it's called as. And every server, so here basically you can have the ODL is acting as a PCE, as a server. And all the nodes are pointing to the PCE, which is the path control element. And it is nothing but the protocol which uses a normal TCP session with 4189 as the port. And just like BGP, these are the message types that they are. To start with, there is one open and keep alive, which instantiates and maintains the PCEP sessions. Then there is a PC request, where the PCC requests the PCE to create a path for it. Then there is a reply that comes from the controller. That reply could be like positive or negative. It could be like, okay, I'm able to create an LSP for you. This is a positive reply given by the controller to the clients. The clients can be anything. It could be any routers that support the PCEP protocol.
Only before prefixes, but in the XRV, you will get the link state updates.
So in there actually, how many BGP peer we will set up? All the
No, again only one BGP peer.
Well, the same as ARAX. For BGP link state, we'll basically export everything that goes from ISIS into BGP.
So to answer your question, it will be just one router that will have the BGP topology or the session connected with the controller, and on yes, that will be the speaker, and on that you will be redistributing OSPF into BGP. That will be learning the BGP link state routes, and through REST APIs you can just read the link states.
if you have some time, 5-10 minutes.
Sure. I mean, yeah. I'm not sure if all the audience will stay till the end.
No,
So
what Ajay is saying is in the PCEP exercise also we'll be using the XRV.
XRVs, yes. So I'll be walking you guys over the PCEP lab, wherein we'll be using the topology, the same topology. We'll be establishing LSPs through different routers. So you'll just get an idea of how the XRVs are used. So, yeah. So. So how many people are aware of PCEP? I know a few of them are here. Okay, guys, how are you doing? Are we all set to continue? So basically, we can still go on to the BGP part, but since we are running late, we'll be uploading the slide deck online, so you have to just go and do a git pull, and you'll be able to get all the contents. So that would include this configuration and troubleshooting steps, basically, whenever you are not able to establish a BGP session and things like that, how to debug all these things, that all these steps are all well documented, so you don't have to, you can just go out later in the day and just play along and try to debug things. So I'll start with PCEP now.
What happened to the other one?
Yeah, so the XRV exercise. The XRV exercise?
No, Giles have set up for us actually.
Yeah, the leak law.
Yes.
Yeah.
Yes. So
That's what he's saying. I mean, we could spend time doing that, but since it's already 4.
No, we have time, don't worry.
There's more stuff to cover. Probably we can come back to it at the end.
yeah. So what we can do is we can. There will be some XRV labs in PCEP also. We can quickly go through that, and if time permits, come back to BGP.
So the only thing that is different with the ExaBGP example that we saw is in ExaBGP there were.
And there are various notification messages, and if there is any error, that gets notified with the PCERR message. So in PCEP, there are two ways you can create a tunnel. One is you can initiate the tunnel from the controller, in this case the PCE, or you can create the tunnels from the PCC, which is called as the PCC initiated tunnels, and you can delegate that tunnel to the controller, saying that this is the LSP I have created. Now you control it. You can adjust the bandwidth or play with it. So it's like there are two ways the LSP initiation process can happen. So any questions so far? Because I might be going a little faster, so please feel free to stop me whenever you want me to. So to summarize this, it's nothing but a client-server communication protocol in a very, very layman terms. And these are the RFCs that are supported in the Opendaylight. The point here to be noted is we have been supporting stateful draft 07 since Beryllium time frame. Before that, we had the stateful 02. And going forward, we'll be continuing to use that stateful 07 draft. And there is also a segment routing